Welcome to the deep dive. We like to jump right into interesting stuff so you can get the key info fast.
Get smart quickly. That's the idea.
Exactly. And today we're looking at something pretty fascinating in AI. It's about, well, how good are these models at recognizing things they've literally never seen?
Yeah, totally new stuff. And we've got some research material here that looks right at that question.
Okay, so it seems to focus on a specific study comparing two different AI models.
That's right. There's, let's call them Model A and Model B. Model A was trained on 29 different categories,
29, okay.
and Model B learned more 47 categories.
47, got it.
So the core thing we're digging into today, based on this study, is this. Which one is actually better at spotting something completely unfamiliar, something unknown? Is it the one trained on fewer things or the one trained on more?
Okay, now this is where I found it kind of surprising. The hypothesis in the research seems to be that the model trained on fewer categories might actually be better at this.
Yeah, it feels a bit backward at first glance, doesn't it?
It really does. Like, shouldn't knowing more things make you better at spotting something different? What's the thinking there?
Well, the idea, and the study really digs into this, is that when a model learns, loads of categories like Model B with 47, it tends to create really specific, almost like tight boundaries around each category it knows.
Okay, tight boundaries make sense.
So when something genuinely new pops up, it's more likely to think, which box does this almost fit into? It tries to like force it into an existing category it knows.
Ah, okay, so it might mislabel it as something familiar, even if it's wrong, like trying to call a platypus a weird duck or something.
Exactly like that. It gets confused because its world is so specifically defined. Now flip that. Think about Model A with only 29 classes.
Fewer things to know.
Right. So the study suggests its understanding is maybe a bit more flexible. The boundaries around what it does know are looser, is the term they use.
Looser boundary.
Yeah. So when something truly new appears, it doesn't necessarily fit neatly near any existing boundary. It's more likely to stand out as, well, an anomaly, an outlier, something that just doesn't belong.
Like the study's analogy, a smaller sandbox makes a totally new toy easier to spot. It doesn't blend in.
That's a great way to put it. It stands out more.
Okay, that logic clicks now. So, how do they actually test this? The material mentions case A and an untrained category.
Right. So case A was the specific experiment for this. They took something neither model had ever been trained on. In this case, it was notebooks.
Notebooks. Okay, totally new.
Totally new. They showed both models, A and B, 30 different pictures of notebooks,
Mm.
and then they just measured, how well each model flagged these as unknown or new.
Okay, moment of truth then. What were the results? Which model did better?
The results were, well, pretty clear-cut, actually. Model A, the one with fewer classes, the looser boundaries was consistently better.
Really, how much better?
Well, they ran 3 test sets. In test set 1, Model A spotted the unknown notebooks 96.7% of the time. Pretty good. Its error rate was only 3.3%.
Okay, 96.7 detection, low error. What about Model B, the one with more classes?
Model B, in that same test, only detected them 93.3% of the time, and its error rate was double Model A's at 6.7%.
Huh. So a noticeable difference already in the first test. Did that continue?
It did, and it got even more pronounced. In test set 2 and test set 3, Model A achieved, get this, 100% detection.
Wow, perfect.
Perfect detection, 0 errors in both those tests.
Okay, and Model B?
Model B stayed consistent. In both test set 2 and 3 was still 93.3% detection and 6.7% error.
Goodness. So averaging that out, Model A is hitting almost 99% detection for the unknown thing with barely any errors, while Model B is stuck around 93% detection and a much higher error rate.
Precisely. Model A averaged 98.9% detection and just 1.1% error across the tests. Model B averaged 93.3% detection and 6.7% error. Significant gap.
That really drives the point home. So the study's conclusion is pretty direct then.
Yeah, the interpretation is straightforward. Model A was just much more accurate and made way fewer mistakes identifying these completely new notebook samples. It directly backs up that initial, maybe counterintuitive idea.
That models trained on fewer categories are actually better, potentially, at spotting the truly unknown.
Exactly. Sometimes less knowledge in terms of category breadth might make an AI more adaptable to novelty.
So the big takeaway here really is that when you're dealing with AI needing to identify things it's never been taught about, less training in terms of the number of classes might actually be more effective.
Less can be more for spotting the unknown.
That's quite something to chew on. It really makes you think about applying this.
Well, it brings up a key question, right? For you, for anyone listening.
Yeah.
What does this mean for real-world AI? Think about, like, fraud detection systems needing to spot entirely new scams.
Or medical AI looking for conditions no one's cataloged yet.
Exactly. Or even just, systems trying to understand rapidly changing online trends. Does this finding suggest we need to be maybe more strategic, perhaps sometimes limiting the scope of what we train AI on, specifically to make it better at catching those completely unexpected curveballs?
That's a really powerful question. Maybe a broad education isn't always the best prep for the truly surprising, something to definitely mull over as these systems get, woven deeper into everything.
Understanding these kinds of nuances is going to be crucial.
Absolutely. Well, this was a fascinating deep dive into how AI handles the unknown. Thanks for walking through the research with me.
My pleasure. Always interesting to unpack these studies.